This is the preview of a practice problem for test 4 of the pre-calculus course. So we're gonna go through several interesting questions from algebra and also from trigonometry. Um, so as the first question, we try to do like testing for one-to-one functions, because this is one of the important topic. Because if the function is one-to-one, then you can find the inverse. Um, So for that, you can either use the definition or the graph or the theorem. We will discuss what we mean by the theorem, because we know that the output values are equal. Then if you can show that the input values are the same, that means the function has to be one to one. This is what we mean by the theorem. But we can look at the actual definition, actual argument in another video. So, and as a second problem, we actually try to find the inverse if the function is one to one. And you can see that in the last problem, the part D, the function is not one to one, but if you restrict the domain, you can make it one to one. So that's why we have that restriction in part D, x less than or equal to -1, so that you restrict the domain so that the function is one to one. And then we can use the four-step method to find the inverse function of that. In problem number 3, so this is like a standard problem for exponential functions. So we're going to use the different techniques, use the taking a ln and equating bases, and then also like taking a ln when you have different bases, and then again like equating exponents, like because the exponential function one-to-one, so we can use that fact to solve certain problems. So these are the kind of things that we're going to do in question number 3. Question number 4 is like basic graphs for exponential functions. We know that there are these graphs are again increasing or decreasing. So we're going to use those facts to graph them, use starting with two basic functions, ax and a to the negative x. In question number 5, this is like basic log introduction. So we're gonna bring it to condensed form and the expanded form for logarithmic equation using those log laws for that. Because we know that the sum becomes a product and the difference becomes a quotient. So that's the kind of argument we can use for these kind of questions. Question number 6. This is like a solving logarithmic equations. So this is like very important topic. So there are several tricks and to do problems like that. So we normally isolate the log term and then try to solve. You try to use the definition to rewrite this as exponent so form. That's what we try to do. So and we also talk about like log e, that means ln, and log 10 and some other bases. Also we do problems with different bases. For example, part D for different bases. And then question number 7 is graphing logarithmic equations. So we do like 3 questions for that. Question number 8 is trigonometry. Uh, so, um, so in trigonometry, we're gonna first talk about like how to convert from radian to degrees and degrees to radians using pi over 180 and 180 over pi factors. And then in question number 9, these are like a standard two standard questions. One is like if you are given a point and how to find the corresponding angles for that. Question number 9. Question number 10 is about drawing angles and then use the reference angle method to find the values. In question number 10, we may basically focus on the reference angle method because that's the kind of fastest and easiest. We also use for that like ASTC argument and the table of common values. So we're gonna see how we can solve problems like that. And you can see angles are in all different quadrants. Question number 11 is about like another standard problem. So like you are given two things, like for example, sine, cosine, sine, tan, and also say like one is positive, one is negative, and also sometimes the quadrant of the angle, and try to find the rest of the angles, so rest of the ratios. So that's the kind of, again, a standard problem. Question number 12 is about graphing sine, cosine functions. So we're gonna use the standard argument. We're gonna find we actually graph in one period. We're gonna use the amplitude, the period, and there's some basic values to graph a problem like that. And also find the domain and range. Especially we find the range using the shortcut method. Question number 13 is about like just to find the amplitude, period, phase shift uh, of these functions. What we normally do is we rewrite this as a standard in the standard form, and then we're going to try to find the those values. In question number 14 is about like how to graph like a general trig functions. So what we normally do is we're going to find those again amplitude, period, phase shift, and then we're going to use those values to find graph a general function. As a final one, this is like one of the important part. This is like finding inverse functions. So we do three type of problems. For example, A and like first two lines are like how to find if you have like inverses and the function together. So we can use certain results for that. And question number E, F are like you can see this is backward. So you are given a value and then you find the angle. And then last three like H, I, and J are like special evaluation problems. You can see those values are uncommon. So what do you do with uncommon values? So this is what we're gonna do in the in this review.